We should remember transformers from paper 1. There are two types, step up and step down transformers. Step up transformer increases the potential difference in the national grid. Step down transformers decrease it to make it safe for our homes. Step up transformers do so to reduce heat loss because they have a lower current, so you have higher efficiency in the wire. Now, here's how a transformer works. You have two coils wrapped around an iron core. Now, in those coils, you have current that flows. So I've got an AC power supply, alternating current, causing there to be current flowing, and the current is alternating so it changes direction. Now we should know in an iron core, if I've got a coil of wire wrapped around it of a good material like copper, a good conductor, it is an electromagnet, which means it has a magnetic field. The magnetic field looks like this, just like a bar magnet. And the key point to note here is that because it's alternating current supply, it is a changing magnetic field. It flips north to south, north to south, north to south, south to north, south to north, usually hundreds of times in a second. So it's a changing magnetic field. So how would you go about answering a question about transformers? First of all, you need to talk about, well, how is there a potential difference? Because questions often ask you about PD. So you'd say an alternating current that in the supply causes an alternating PD in the primary coil. So let's label that up here. Primary means the first coil, usually it's on the left. Now, once that happens, then what we have just drawn out is that this generates a changing magnetic field. You've got to say the word changing for questions involving transformers, a changing magnetic field in the primary coil. Now, as well as that, there's also a magnetic field in the iron core. Iron is chosen because it's magnetic, so the magnetic field also is present in the core. Now, because of that, on the right-hand side, we don't have a power supply, but in the secondary coil, which is on the right-hand side, there is an alternating PD, not generated, but induced. That phrase that talks about how PD arrives on the secondary coil, and that's because you have a changing magnetic field in the coil of wire. Now, if it's connected to the circuit, I've drawn an ammeter there, there's alternating current, which you could talk about. Now, important to note here is the current doesn't travel between the coils. Iron is not chosen because it's conductive. The coil is actually insulated, but they are not connected to each other. So let's talk about these different types of transformers then. So the one I've drawn here would be a step-up transformer, because if you count the coils, there are more coils on the secondary coil, which I haven't labelled, but it's the one on the right. More turns on the secondary coil compared to the primary coil. So you're going to have a greater PD induced on the secondary coil. If you remember from the generator effect video, a greater PD is a result of more turns, one of the factors that affect it. Now, there is an equation that governs the number of turns and the voltage, or the PD, on each side. And it says that if I know the number of turns on the primary coil and divide it by the number of turns on the secondary, that is the same as the ratio between the voltage, or PD, on the primary coil versus the secondary coil. So this will be written out for you and given to you in an exam, and see my other video for examples of this. But my top tip, this equation can be tricky. If you're trying to find something that's on the denominator, you can flip both sides of the equation round. So let's say you're trying to find the number of turns on the secondary coil. It's quite hard to find because it's on the bottom of a fraction. You can flip both sides over to make it easier for yourself later on in the question. So that's transformer equation 1. Transformer equation 2 is to do with the efficiency of a transformer. So they are very efficient, and so we make an assumption that they're 100% efficient, which they're not exactly, because there's always going to be heat lost in an electrical circuit. But if they're 100% efficient, we say the power in is equal to the power out. Now, from paper 1, you might remember an equation that is power equals PD times current, V times I. So what we say then is that the PD times current on the primary coil equals the PD times current on the secondary coil. And that's transformer.